Hello, people. Welcome to Gurukula. I'm Jay. In recent times, there has been a huge evolution of AI and AI related tools for almost all of our day to day activities, be it journaling, content creation, designing, education, and whatnot. The list goes on and on. Due to this rise in AI technology, there are also lots of firms stating that AI would take away our jobs. But I do not agree to those statements. All we need to understand is that AI is going to be an integral part of our day to day life as we have mobile phones now. In my perspective, AI will not take your jobs, but those who understand AI will. Mastering the art of interacting with AI models will not be an option anymore. Let's quickly ask the AI to generate the skills that different professionals would require by the year 2050. So here is the AI generated skill set for a web developer who is about to be recruited by the year 2050. Interestingly, we could able to see that AI has named them as metaverse architects. And if you could observe, they should master the technologies such as 3D, mixed reality, and AI. Next, I will be very interesting to see what are all the skill sets that a teacher will be requiring by the year 2050. Surprisingly, even the teacher would require AI skills to cater the needs of the students for personalized learning experience, and they may be capable of creating AI AR VR friendly lectures with the help of artificial intelligence. Next, looking at an architect's skill set, they should also master the AI skills for the purpose of automation and building future proof designs. Similarly, when we change the professions to accountant or any cybersecurity analyst, we could observe that there might be a strong knowledge that everyone should possess in the field of artificial intelligence. You could observe that AI's influence spans across all domains and sectors, making it vital to acquire proficiency in utilizing AI tools and models for the future success. Moving on to the next part of our session, we should understand why would we need prompting. Randomly picking any job or profession, the internet is flooded with ample amount of AI and AI related tools that completes the task quickly and autonomously. I would like to introduce to this particular platform AI Directory Futurepedia.io, which will give you a list of AI tools which is of both paid and free. You can able to explore this particular website to find the AI tools for different purposes such as productivity, video generation, text generation, image generation, and any AI art generations. There are certain tools to generate codes as well. Here are some tools and platforms that are really worth mentioning before we actually move around. Here is a Google Gemini, which is a chat assistant. So here is another particular website, an Agent GPT, where you can able to create several agents and you can chat along with them. Here is Piggy.to AI's interface, which could able to generate image and videos according to your instructions. Next, moving on, another interesting AI website is Pollination.ai, where you can able to create any image according to your instruction. Then aipage.dev, which will create interesting landing pages for any businesses according to the instructions that you give to this particular web. And next, moving on to Microsoft side, we have Copilot, where you can able to browse and you could able to ask this AI to do any sort of work that you do along on the internet. It can able to generate text, summarize the web pages, and much more. And another one is Microsoft Designer, where you can able to create interesting designs through the instructions through which you give through the website. So this is where actually prompting comes into the picture. So prompting is nothing but it is the way of interacting with AI models. If you observe this or any AI related models that is flooded on the internet nowadays, you could crucially observe that the only way that you can able to interact to this particular models is through the prompts. Only if you give the correct prompts or only if you give the structured prompts to the AI model, you could able to generate any text or you could able to generate any image according to your requirement. To get a right output, you need to ask the right question. Without any further delay, let's get into the topic. In this session, we are going to cover these topics that you can see on screen. First, we will try to look into the future through the eyes of AI. Moving on, we will be trying to understand the difference between artificial intelligence, machine learning, and then large language models. And then we will try to understand what are all the capabilities of the large language models. And moving on, we will be trying to understand what prompts are and how prompt engineering will be really helpful for us to get our works done. And followed by that, we will be focusing on the best practices and few key elements for an effective prompt, and followed by what are all the types of prompts that we can use in order to get an effective output. AI allows us to look into the future. Let's look into the future through the eyes of AI. So here I am very interested to see how the classrooms will look like by the year 2050. So when I ask my AI model to generate how the classrooms will look like by the year 2050, here are the images which is thrown out by an AI model. And all these AI images, whatever been projected, is generated by various AI models. So you could able to see that the classrooms are really personalized. We could able to see that the classrooms is very much modernized and it is very futuristic. And the happy part is AI has not eliminated the teacher inside the classroom. Next, we will see how the health cares will look like. Surprisingly, we could see lots of greeneries present inside the building, and the building is also very futuristic, and we could able to see how the healthcare would look like in 2050. Moving on to how the automobiles would look like, we could able to see that these are all the type of automobiles which could hit the road by the year 2050. And looking into this futuristic design, we could able to see that most of the cars are self-driven cars and it resembles the electric vehicles design. And when I asked to see a random street in India, how a random street in India will look like by the year 2050, interestingly, we could able to see that these pictures, when you look at the image on the left, you could able to see that the robots and the humans coexist together in the streets. So this may happen in future, and this is how the AI is visualizing the future. And finally, let's see how the agriculture in India will look like. We could able to see that the human is controlling the cutting edge AI technologies, and we should be happy that the AI has retained the traditional as well. We just visualize the future through the eyes of AI. Moving on to the next topic, we shall try to understand the difference between AI, ML, and LLM. To understand what exactly prompt engineering is, we should first need to grasp all these three terminologies very precisely. First, we will try to understand what artificial intelligence is, and then we will try to understand what machine learning, and we will try to contrast the difference between artificial intelligence and machine learning. And with this knowledge and context, we could able to understand what large language models are. After understanding all these three terminologies, we will see how a prompt can be useful, and we will discuss a lot on what exactly the prompts are. First, what exactly artificial intelligence is. AI is nothing but the computer is programmed to think like humans, enabling them to perform any complex task. Let's try to understand this particular terms with an example. Assume that I just wanted to solve a Rubik's Cube and a human wants to convey this particular information to a machine. So just by telling a machine to solve the cube, your machine does not initially know about what this Rubik's cube is, and it is going to throw you an error like, what is this? It's obvious because initially machines do not know anything. So in order to make my machine to solve this particular Rubik's cube for me autonomously, we should first teach the step-by-step algorithm to our robots to solve this particular Rubik's cube. Once this is done, and then if you give an instruction to solve the cube, yes, cube is going to get solved and your machine is going to execute the instructions step by step, whatever it is been programmed to do so, and finally the cube is getting solved. I believe that this gives you a basic understanding of what artificial intelligence is. So we are artificially giving an intelligence to a machine through program so that your machine can able to solve the program in a prescribed manner. Having that in mind, what if we change the Rubik's cube, or if I give any different kind of cube? So we cannot say that my machine is now capable of solving all sort of Rubik's cube. Here is a scenario. So if I say a Rubik's cube which is of different size, which a robot is not programmed to do so, a robot is not going to solve it because it is only programmed to solve a 3 by 3 Rubik's cube, not a 5 cross 5 Rubik's. So this is where actually the machine learning has its importance. The machine is not learning, the machine is actually executing the task whatever it is being programmed to do so. So that is what artificial intelligence is. It just executes the program step by step. So that's where the machine learning comes into the picture. So let's see how machine learning is in contrast with artificial intelligence. So machine learning is like teaching the computers to learn from examples and get smarter over time. The robot is like a student who just memorized the step but struggles with a new puzzle. As like our AI robot could not able to solve a 5 cross 5 cube. Instead, if you teach your robot of how to solve a Rubik's Cube with some examples, then your machine learning robot will actually start learning that. Machine learning lets the robot to learn on its own. Imagine you are giving the robot a variety of different cubes, and instead of telling it each and every step through algorithm, we show them how to figure out the solution by itself. Now our robot becomes a learner, and that is instead we call it as your machine is actually learning. So based on the examples that you have provided on how to solve a particular problem, your machine starts learning on its own, and it itself figures out a way to solve any sort of Rubik's cube. Once the machine is trained in this particular way, if you say or if you throw any sort of puzzles and if you ask the robot to solve the cubes for you, that's easy. Your robot is going to do that and your robot is going to solve it for you. That's the essence of machine learning. So in machine learning, we provide the robot with a bunch of examples and let it discover the patterns and rules on its own. It's no longer about just following the instructions as we did in artificial intelligence. It's about the robot adapting and getting better at solving cubes. So when we talk about machine learning, we are talking about the robot that goes beyond just following a set of given instructions. It's a robot that learns, evolves, and becomes better at its task over the time, just like a student getting better at solving puzzles with practice. So AI is like instructing a machine to do some particular task, whereas ML is a subset of AI where we are teaching the machines to improve tasks autonomously through data. So there is a substantial difference between instructing and teaching. To sum it up, if programming the steps of Rubik's Cube was artificial intelligence, then teaching the robot to learn and adapt to new puzzle is machine learning. I hope by this time you should have a clear and distinct difference between artificial intelligence and machine learning. With that said, let's move on to large language models. Shortly abbreviated as LLMs, is a type of machine learning model specifically designed for understanding, generating, and interacting with human languages on a large scale. In terms of its relationship with ML, LLM can be considered as a subdomain of machine learning, and it basically operates on natural language processing. Natural language processing is a subfield of machine learning which mostly focuses on interacting between computers and humans. So the primary goal of NLP is to enable machines to understand, interpret, and generate human-like text in a way that is both meaningful and contextually relevant. We already have some examples in real-time situations like Alexa, Google Assistant, and Apple Siri. All these applications take natural languages from human as input, and it processes the language and it gives us the meaningful responses. So hope you now could able to differentiate what AI, ML, and large language models are. So artificial intelligence is instructing a machine to do a particular task. Machine learning is teaching a machine to solve any particular robot, and it evolves over time. And large language models are basically operated on NLPs, natural language processing, which is trying to communicate between humans and then the computer in very natural way. Moving on to the next topic of our session today, we will explore what are all the possibilities of large language model. Looking at the possibilities of large language model, can be used for content creation. Your large language models could be able to create enormous amount of content, be it for social media, be it for your YouTube and any sort of applications. And next, it can be used for text summarizations. Imagine that you have huge PDFs to read, huge research papers to read. You have AI tools in place which could be able to summarize and to give you in a capsule form what is actually there on the paper, where actually you could save huge amount of time. And you can use it for language translation, which in turn you can learn a new language by just interacting with your AI model. And next possibility is you can use the chat GPT or any large language models as conversational agents, which means if you have to speak to an scientist or if you have to speak to an expert in a particular field, then you can tune your AI model in such a way that it responds you as an expert. And the next possibility of LLM is sentiment analysis. Imagine that you have a list of customer feedbacks which you have received on your product, and if you could able to analyze the sentiment analysis, then your large language models could able to actually interpret what is the overall result of that particular product. And you can ask several questions and you can expect your AI model to respond to your questions, and your LLM can able to generate codes basically supported on any programming languages like Python, C, C++, Java, HTML and so on. And you can actually personalize the content whatever that you have written. Imagine that you have written a blog, and if you would wish to change the tone of the entire blog, you can ask the LLM to do so. All these possibilities can be done with the large language models, and we have tools in place to work around. And this is not the list, and there are much more things which we can do with LLMs. Moving on to the next topic of our session, understanding what is a prompt and prompt engineering is, which is a primary focus of this particular session. What exactly prompt engineering is? Assume that there is a human being who is trying to interact with an highly technological robot, and this interaction is not so easy because system understands in different perspectives. Humans will have different perspectives. So when there are two people interacting with different perspectives, we may not expect a proper outcome. So in order to get the correct answer from your highly trained machine, you need to ask the correct question. And this is where exactly the prompt engineering comes into the picture. Prompt engineering involves crafting or constructing your prompts in such a way that they produce specific desired responses or behaviors from any AI or machine learning model. Now we will try to understand a prompt engineering with some basic examples. You could see a prompt here, an unengineered prompt. If you feed this particular prompt to your AI model, tell me about dogs, and your AI model is going to give you huge amount of data which is irrelevant or out of context. And this particular prompt is unengineered because it is quite broad and it lacks the specificity. So if it is used directly with generative AI model like ChatGPT, you could able to see what is the output which is being generated by the ChatGPT on your right hand side. It might generate a general response about dog, but it is not deliver the specific information or depth which is actually desired by the user. On the other side, if we have to engineer this particular prompt, look at the much more refined prompt which you can able to give to your large language models. Instead of asking just to write about dogs, you can able to give describe the unique behavioral traits of Labrador retrievers compared to other breeds. So here my prompt is well engineered and it is more specific and directive. It guides the AI model to focus on a particular aspect, which is behavioral traits of a particular breed. It prompts the AI to produce a more targeted and detailed response, potentially offering insights into Labrador Retriever behavior that differentiate them from other breeds. There are a few best practices for prompt engineering. Understanding before we actually get into seeing the elements of prompt engineering, we should first understand how humans and LLMs read the prompt. From the human perspective, let us consider this particular prompt enhance the content of the document. If this is the prompt which is given to a human being first, then human can able to understand this particular instruction from his experience and the contextual understanding that he has. So humans is absolutely going to understand what we are trying to say, and any human being can able to improve the content of the document, especially from his experience and contextual understanding. But that is not the case with the LLM. Your LLM will get confused on what to enhance, whether the quality of information has to be improved or the language has to be refined, whether the writing style has to be redefined for better clarity, adding more relevant details, restructuring the paragraph, or enhancing the visual elements. In which aspect the document has to be enhanced. So there are these many possibilities to enhance the document, and moreover, whether all these enhancements has to be done for a part of the document or for the entire document. So here there is a distinct understanding that how the humans will understand a prompt and how the machine struggles to understand this particular prompt. So if there is a difficulty in understanding the prompt, then definitely we could not expect a absolute result from the AI model. Now let's try to see how the LLMs will understand this particular prompt. Any LLM, when a prompt is given, it will try to understand with the help of tokens or the keywords present in the prompt. First keyword which is present in this prompt is enhance, which indicates that it needs an improvement. The second keyword is content, which refers to the data within the document. And finally, there is another keyword called document, which specifies the target for enhancement. So that is how the LLM will understand the prompt which is being given. And now LLM actually struggles in understanding the specificity, the scope, and then the context. In the given prompt, the prompt does not define the exact nature of the improvement. Example, whether the language has to be refined, or if there is any data has to be added in addition, or restructuring is required in order to enhance the quality. Next, the struggling is on the scope. Without further guidance, your LLM or any AI model, it might not identify the specific section or the topic within the document that needs enhancement, whether the entire document has to be improved or it is only the section which needs improvement. And based on the context, LLM lacks the broader context of the prior knowledge. The LLM doesn't know what exactly the document is all about. So as per the human beings, our example prompts enhance the contents of the document in order to do the same thing which LLM. This is the refined version of the prompt. So when you look at this particular prompt, this is even more descriptive and LLM friendly, so that this particular engineered prompt can help the LLM to generate more accurate results. Now let's decode this engineered prompt for better understanding. Let's decode this particular prompt. The first is improve the content, which actually indicates the action that is required. And here the required action is to enhance the material. And the second part is revising the introductory session. This actually specifies the targeted area for modification. We are actually specifying which part of the document needs modification, and incorporating additional statistical data clearly specifies that what type of enhancement has to be done. So enhancement has to be done by adding additional statistical data, and similarly where it has to be added at the third paragraph. So all these informations are in place. And finally, you are suggesting visual aids such as graphs or charts. Again, this comes under specificity and clarity, which provides clear examples of enhancement of the document. Now I believe you should have understood the importance of engineering a prompt. So it is not one and the same just by telling improve the document and by providing the most engineered version or optimized version of the same prompt which we have just discussed. So next, moving on to our next session, we will be discussing the key elements for a successful prompt. So there are five key elements for a successful prompt: clarity, specificity, relevance, actionable, and contextual. Let's see one after the other. So first we will talk about the clarity. Here, clarity with respect to LLM means that providing explicit and unambiguous instruction or information that leaves no room for misinterpretation. Now let's have an example. Here is an prompt which actually lacks the clarity. Explain about science. So this is very vague and we cannot able to expect your LLM to generate more accurate results. But whereas we have an fine-tuned version of the same prompt which has the clarity. So here, if you look at the engineered prompt for the clarity, you could able to see that discuss Newton's law of motion and their application in real life scenario. So here the prompt is actually very clear and the LLM is being instructed to give precise information about Newton's law of motion and also their application, and now it is not in general about science. So this is a very good example that states what exactly clarity is with respect to LLM. Moving on to the next element for a successful prompt, it is specificity. Specificity is actually providing clear and detailed instructions for the LLM. So here is an prompt which is lacking with the specificity. Create a presentation about science. Again, though the prompt is very clear that the presentation has to be made and on the topic science, but it lacks this specificity. Now let's see the most refined version of this. Here in this particular improved prompt, we can able to see that I am restricting the AI model to create a 10 slide presentation specifically on the advancements in solar and wind power technologies. Moving on to the next element for a successful prompt, that is relevance. The relevance with respect to LLM means that it aligns directly with the intended purpose or a goal. Let's try to understand with an example. So here is an example. Explain the process of photosynthesis in plants. Though this particular prompt is clear and specific, but this lacks in which relevance the photosynthesis has to be explained. Whereas on the other side, we could able to see that there is a more refined version of this where relevance is also added to this particular prompt. Here, AI model is being instructed to generate content that is related to photosynthesis with relevance to maintaining ecosystem in balance. Moving on to the next element for a successful prompt should be actionable. Actionable means you should clearly outline the task or any action which has to be carried out. So initially here we could able to see that discuss the future of the technology. Here discuss is the action word. Now we could see the more refined version of the same prompt with actionable content. So here we are actually directing the AI model to predict the advancements in artificial intelligence. So this prompt is more actionable and we are very clear, specific, and relevant to the topic. Moving on to the next element for a successful prompt, that is contextual. The contextual information in LLM means that providing necessary background information or any additional informations that supports for better understanding or execution. So here we have a prompt which reads summarize the impact of quantum mechanics on modern physics. Though the prompt is clear, specific, relevant, and actionable, there is a lack of contextual. Let's see how we can rewrite the same prompt with a contextual aspect. Just by adding a line that here I am asking the AI model to summarize the role of quantum mechanics in shaping the field of quantum computing, thereby outlining. How do I need to outline it? With the key principles like superposition and entanglement, and I also instruct my AI to include their applications in cryptography and computational efficiency. So my context is very clear, it is specific, it is relevant, it is actionable, and it is contextual. To sum it up, so these are the five elements for a successful prompt. Your prompt should be clear, it should be specific, it should be relevant, it should be actionable, and there must be a contextual data to aid towards more preciseness. With this, we are moving on to the last topic of our session, that is type of prompts. Though there are different types of prompts, and we are going to see the major five types of prompts, that is zero shot prompting, one shot prompting, few shot prompting, multi shot prompting, and chain of thought prompting. Let's see one after the other with an example. First, we will look on zero shot prompting. The zero shot prompting is nothing but you are telling the AI model to respond only based on its trained information. So, to respond to any sort of question, it relies only on its general knowledge and adaptability. So, usually, this type of prompts will be used for language translation, just like that, you can ask your AI model to translate a particular text to some other language, or it can be used to solve a math problem, or this can be used for general knowledge queries. Moving on to the next type of prompt, that is one shot prompting. So one shot prompting is used when you want the AI to understand the context or style of the task with just one example. So it is as similar to giving one dish to the chef, and the chef is being asked to taste the dish so that he can able to cook something similar to that particular dish. So you are providing with one example with one shot prompting. So that is what we call it as one shot prompting, and this can be widely used in the use cases, like it can be used in education, asking your AI model to break down the complex topic for different age groups, or you can ask your AI model for any customer services for setting up the tone and content creation. Moving on to the next prompting method, we have few shot prompting. So here few shot prompting provides the AI with small set of examples to help it understand the task and generate the appropriate responses. So this type of prompting is almost similar to showing a beginner player like a few moves in the game to help them learn the rules and strategies quickly. So you are showing certain moves of any senior player so that he could able to look at the moves and he could able to understand how the moves are being performed. This type of prompts is almost similar to your one shot prompting, except you will have multiple training sequences or any additional informations except for the one which you have seen in the one shot prompting, but still we can able to see some examples on few shot prompting with the help of ChatGPT. Moving on to the next type, we have multi-shot prompting, where multi-shot prompting provides the AI with multiple examples so that your AI can able to grasp a complex task or a pattern before generating its own content. Usually, these type of prompts can be used for legal analysis, whereas you can give two different cases as an input and you can ask the AI model to come to a solution or any analysis that can be done, and you can use it for healthcare consultation. You can feed in any health informations and you can ask for any symptoms, what type of symptoms, those things can be done, and we can do a market research based on the customer feedback that we have received on our product. Moving on to the next type of prompt that we have in our list is chain of thought prompting. So a chain of thought prompting is like asking more and more questions to keep the conversation going on. It is more similar to like asking a follow-up question for any response that your AI model has given. The popular use cases of a chain of thought prompting is to have a creative writing or to explore even deeper or to understand the concept, and you can able to direct the AI model to explain in a different perspective. So with this, we have came to an end of this particular session. And to summarize what we have seen in this particular session from the beginning, we have just seen that AI is not going to take your job, but those who understand will AI will certainly going to take your job. And with that, we have observed that AI is influencing across all of our domains and sectors, and it will make the art of interacting with AI models and mandatory skill. And we have seen that the only way to interact with AI models is by giving the prompts, and we try to understood what prompting is and how important the prompt has to be engineered so that we can able to get a precise output from the models. And we have seen the future through the eyes of AI, and we try to understand AI, ML, and then LLM, and to contrast the difference between these terminologies. And followed by, we have just explored what are all the possibilities of a large language model, starting from content creation to personalization. And then we have seen a prompt engineering. How does an unengineered prompt will look like, and how engineered prompt will look like. And we also understood how a human will look at the prompt and how an LLM will look at the prompt. And we realized the importance of fine tuning a prompt before feeding it to an LLM. And then we moved on and we discussed the key elements for a successful prompt. There are five key elements: clarity, specificity, relevance, actionable, and contextual. And it need not necessarily a prompt should have all five elements. Depending upon the situation, depending upon the requirement, you may have one or two in place. And finally, we have discussed five different types of prompts: zero shot prompting, one shot, few shot, multi shot, and chain of thought prompting. So I believe that this session might have been useful for you in understanding how you have to interact with AI models. And with this, I'm going to wind up this video, and I'm going to see you in the next video. Until then, it's bye from Jai and happy learning.